All right, so let's talk about this sigma thing. All right, so I find that this is the one thing that trips kids up. So all this means right here, this is a Greek letter for just representing a sum of numbers. It's actually the Greek symbol for S. So the one thing that sometimes confuses kids or students is the whole notion of I. All right? So I is not the first term. This isn't going to make sense at first, but just bear with me, okay? I is actually what we're going to substitute in to find the first term. Okay? Don't worry. It'll make sense later. All right. So I'm going to actually try and substitute in a 1 to find my first term. So let me do this in red. And I need to change this again. I should have done that before you guys came in. I'm sorry. Because then it's just confusing. Okay. All right. So let's start. And then I confused Miss Wiz yesterday with doing that. And she corrected me, and then she put it in the presentation. Remember? Okay. So a sub 1 equals 6, substitute something in for I, minus 5. So this number could be a 5, a 10, an 100, but I'm going to use it to find the first term. It just happens to be 1. They just happen to match, but that doesn't always happen. Okay? So I'm going to substitute in 1. And I'm going to get 6 times 1 is 6. 6 minus 5 is 1. Now I'm going to find my second term. So in order to find my second term, I now have to go up from 1, which is now 2. So this is 12 minus 5 is 7. My third term, now I'm actually going to skip a step because under here I've got this all written out. Do you see that we're jumping by 1 plus 6 is 7, 7 plus 6, 13 plus 6, 19, and that's as far as I have to go. I substituted 1, I substituted in 2, then 3, then 4, and 4 was as far as I had to go. Wait 1 second, Philip. Let me just finish this. Okay, so I'm going to show you this underneath here, but I want to show you how we got it. So let me erase this, or we'll leave it up for a second. I think it'll be okay. All right, do you see it? So this is the first one right here, first term. Here's the second term. Here's the third term. And the fourth term. Just had to substitute in 1, 2, 3, and then 4. And that's where we came up with a sub 1, a sub 2, a sub 3, a sub 4. So yesterday, or previously, we would come up with, we would be given this, and we would have information that we would get out of it, right? We would get a sub 1. We'd also get how many terms we have, and we'd also get how much we jump. I'm going to do this one in purple. So that's adding 6 each time. Did anybody see a correlation? It's like slope, right? You're jumping 6 every time. Okay, so how many of you are thinking, I'm going to underline it. How many of you are thinking, where in the world did this come from? Like, they just pull it out of the air? Like, where does that come from? Only one of you? 2, 3? I mean, that's the first thing that comes to mind with me. Like, I want to know what that is. Philip just pointed to the wall, to the board. Why? You're right. It came from this right here. That's why I'm asking you. It came from the explicit formula for arithmetic. We're talking about arithmetic. I'm going to show you right now. Okay. Wait. No questions yet. It breaks people's concentration. Okay. So if I tell you that it came from the explicit formula, which is a sub n equals a plus 1, a sub 1 plus my common difference times how many I have minus 1. So I'm going to go ahead and substitute some values in here. A sub 1 is my first term. My common difference is 6, or we found it this way, 6. Correct? A sub n equals 1 plus, here was one of the mistakes on the homework. I'm not on homework, on the quiz. Some of you added 1 plus 6 is 7. You can't do that. Order of operations says I have to use the parentheses first. Parentheses have a 6 that needs to be distributed first. Somebody make that mistake? Not many did, but some of you did. Why is it not erasing? Okay, there it goes. Okay, so if I distribute, I get 6n minus 6. If I further evaluate this, a 1 and a negative 6 makes a negative 5. And it is the same thing as this one. Now, you don't have to write it down, right? But it's interesting, right? You guess. So now, instead of finding this, we're going to use this tool right here to cut all this middle work out. And I'm going to explain that right now. Philip, say it louder. Why do we only want it? You're jumping ahead. What's going on? You're just like the wheels are spinning right now. I love it. Okay. Was that the only question you had?
Oh, no. Is I always going to be 1?
No, it's not. That's a very good question. Okay, it's not always going to be 1. That's why you can't look at it as the first term. It's just the first number you're going to substitute in to find the first term. Okay. So I'm going to see like light bulbs going on all over the place throughout this presentation. I know it. Okay. By the end, you're going to be like, wow, that looked so much harder than it actually was. All right. So again, we got to change these. Bear with me here for 1 second. It's hard to explain. It's because we normally write n. And when we're writing, the common difference, we write that next to n. So we tend to put that in there. And sometimes in some books, it is n, but you should know then they'll put n here too. And then it's really super confusing. Like, which one's n, So that's why we made sure to try and keep it all I. All right. So all we're going to do is practice these sums. So I'm going to go a little bit quicker here now, and I want you guys just to pay attention, and then I'll let you write one down. Actually, you probably don't even need to write one of these down in your notebook. We'll wait till we go all the way through it. I just want to see if you guys are kind of catching on. Okay, so let me change my pen, and I'm going to find my first term, which is 2 times some number plus 3. My second term, 2 times some number plus 3. How many terms am I going to have? 1, 2, 3, 4, 5, 6. I'm going to have 6. You know what? I promised you a clean model, so I'm going to go ahead and do it. All right. So what goes inside of here? First, I'm going to start with a 1, then a 2, then a 3, then a 4, then a 5. I need one more. I know I need one more because I have to get to 6. Right? You keep adding until you get to this number right here. It is just a number. Like, for instance, this one, we're going to start with 5. That's such a good question. So if we were doing this one, I would have a 5, then a 6, then a 7, then an 8, then a 9, then a 10. It's almost like I should start with this one, huh? Yeah. And then come back? Let's switch it. No, it's not going to, watch. It'll be easier. So I'm going to switch these. Okay, since I already have it there. Not that big of a deal, right? Okay. Improvising. Okay, so now what goes in here? Oh, shoot. It is. I can still do it. There we go. Okay, are we good now? Okay, no questions yet. Okay, so what goes, so this is the formula, right, to find all the terms. So what goes in here? I put the first one is a 5, then a 6, then a 7, then an 8, then a 9. Good job. Nice catch. You guys are awesome. You're so forgiving, non-judgmental, right? Okay. You should be like proud of yourselves right now, right? Okay. So 2 times 5 is 10, plus 3 is 13. 2 times 6 is 12, 13, 14, 15. I really don't have to do this anymore. Why? Because I'm adding 2 each time. That would have been easier, right? Let's check. 2 times 10 is 20, plus 3 is 23. We're right. So this actually matches right here, right? So I'm jumping, plus 2, jumping, plus 2, jumping, plus 2, matches right there. All right. Yes, sir. It's like an organization. It has all the information you need, and you're going to see why in just a second. Okay? It's like if you have this, you don't need the big, long series of numbers because you only need to pick a couple pieces of information out of it. Yes?
Okay. So when we do the whole list of numbers, are we going to do what we did yesterday too?
We're not going to do the big, long list of numbers.
Oh, that's just for example.
This is, you need to understand where everything comes from, right?
So we're not actually.
You know me. I don't just like show you how to do it and tell you to do it over and over again. I want you to understand why you're doing it. Okay? Okay. So can you guys give me the, how much time do we have? We got quite a bit of time. I think I'm going to move forward and have you show me as we go. I think that's what I'm going to do. All right, so today you'll be modeling arithmetic series with an equation, and you should be able to define what arithmetic series is and describe the components of sigma notation. Okay, so this is what we did yesterday. Hopefully you did it on your homework, and we came up with a formula. I know why it's doing that, because I'm touching down here. Okay, and I just did it again. All right, so the formula we came up with is we decided for some n number of terms to find the total or the sum of all those terms, I would take my first term and my last term, multiply by how many I have, and divide everybody by 2. That's the same thing as this. Can I show you? So S sub 9 equals, I talk it as I go through it. I'm not starting with the 9. I'm starting with what I'm doing to get the 64. So here's my first term. Actually, it was 4, right? The original one is 4. Okay. My first term is 4. My last term over here is 60. How many do I have? 9. And I'm going to cut them in half. Now, the reason I do it like this instead of this way, right, this could be changed to this. 9 over 2 times 64 over 1, right? And it would just turn into this. Do you guys see that? No? Nine over 2. And 64 over 1 turns into 9 times 64 over 2. Basic fractions, multiply across. Okay, this is why this is easier. Now I'm going to teach you a couple things in here. This is remedial, right? Okay, can I do this? Okay, I have a question. Where did 2 come from? Which 2? This right here? This is what we did yesterday. Remember we counted from the bottom of the rows from the movie theater up, and then somebody counted from the top down. So we had 2 people counting, right? So since we had 2 people counting, you always have to divide it by 2. So instead of writing it like this, I'm going to do it one more time because I think we need it. So instead of writing it like this, I'm going to write it like this. I'm going to add my 60 and my 4 to make 64, multiply by 9. 9 terms, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 64s. I'm so glad I did this one more time. 9 64s, but since I have 2, I have to divide by 2. Okay, so that's what I'm trying to get across to you guys. Dividing 9 by 2 is the same as dividing 9 and 64 by 2. One more time. 9 divided by 2 times 64 can also be written 9 divided by 2 times 64 over 1, right? Which is, if you multiply across, it looks like that, right? Okay. I want to make sure we're all on the same page. Okay, another misconception. Some of you will do this. Oh, I can just cancel that 4 and make it a 2. No, you can't. No, that's right. This is why. You can't do that because this is not 4 divided by 2. It's 60 plus 4 divided by 2. It's 64 divided by 2. So please don't make that mistake. I'm almost losing you, and I'm going to move on in just a second. Okay, this is why I like to do it this way. Nine is not divisible by 2, right? So that's kind of messy in itself right there. But 64 is, right? So this I could change to, what I normally don't do this though. 64 is actually 32 times 2, or 8 times 8, right? You guys laugh now, but you're going to see that it's going to help you out a lot. Philip will let you know. Okay, so now I have 9 times 32. What's 9 times 32? Well, 9 times 30 is 270, and 9 times 2 is 18. So 270 and 18, 288, right? I'm going to do that all year long, right, Philip? Okay, I'm going to say it again. We're going to do, we could do number talks, right? 9 times 32, I'm going to talk out what I just did in my head, is just like 9 times 30 plus 2. 9 times 3 is 27. Add the 0. 9 times 2 is 18. 288. It's just mental math. It's just thinking stuff out in your head. We're going to do, it's number sense, and we're going to do it all year long. Okay? Alrighty. So, do you guys want to write this one in your notes as an example? Let's do that. Okay, so get your notebooks out, and I'm going to pause the video. Let me highlight what you should write. All you should really need to write on this would be this, and then this. That's all you really need. What's in green? I'm going to erase this other stuff. We're going to put this in blue. And then I'll put the pieces of information. Okay, so if I'm using this formula, guys, I need a sub 1, which is my first term, number 4. I need a sub n, Philip. What's a sub n, Philip? Philip, what's my last term? And the only other piece of information we need is n, and we found there are 9 terms. Because it's the last one. It does, and in this sense, it's the last one. Because there's no more. No, n does not stand for no more. Okay, I'm going to also get rid of this. Sorry, don't kill me. Oh, shoot. Okay, what's in green is what you should have. This is the formula. This is what we pulled out of our series, and this is how we used it. Okay? This is going to be Arithmetic Series. Okay, recording. So if Gauss looked at this and said, okay, if I reverse it and put 100 over here and 1 over here, then I would have 100, 100, 101, but I'm going to need to divide by 2. See what he did? Then he said, okay, so half of 100 is 50. Therefore, 50 hundredths is 5 hundredths is 500. Add the 0, 5,000, plus 5 ones. Sorry, I said it wrong. Okay, I'm going to cover up the 0, then I won't mess up. Okay, so 500 ones. Well, 5 times 100 is 500, and 5 ones is 5, so 505. There we go. Add a 0. So he did that in his head. He said 5,050. He made sense of it in his head. I don't know. I wasn't there. No. You only have, I can't let you anyways because 10-10 rule. Okay, so we're going to do this together now. Nope. Okay, so we're going to switch this. I want you to put this in your flip, on your flip book really quickly, 1 minute. You got to write it out, but we're going to change it to, we decided we weren't going to use that formula because we want to be able to cancel, right? Cross cancel, right? So instead, we're going to talk about, I'm in white, the first term plus the last term so many times divided by 2. So write that down. You guys have 1 minute. Continue. Okay, recording. So I'm going to do this one quickly. I actually already just did one really quickly. Why don't you guys do one? How many of you would like to sum this up by adding them all together?
No, you just add first and last name.
That doesn't look like a lot of fun to me. So in order to add them all up, we're going to use our formula. So we're going to use our first term plus our last term n number of times divided by 2. All right, so what I want you to show me on your whiteboards is not the total, but can you find the first term and the last term? Yeah, show me the total. Let's see how we do. First term, last term, total. I don't know what I'm having such a hard time with. Yes. First term. This is what I want on your whiteboards, guys. A sub 1 equals, A sub n equals, and the total sum is. Go. Okay, so I've got about half of you that got it. I'm going to do it really quick. A sub 1 is 1, right here. A sub, here we go. Let's do this. A sub 1 is 1. A sub n is 3. You needed the total number of terms. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms to use the formula. So I'm going to add my first term and my last term times how many terms there are and divide by 2. The total sum. S sub n means my total sum. Okay, questions? Hold on, I'm going to pause it really quick. Okay, so recording again. So now we're going to go back to our summation formula. All right? I'm not going to use this one. I'm going to use this one because it's got the 6 and the 12. All right, so here's the information I can get out of this. I can get my A sub 1 because I'm just going to substitute in 6. I plus 4. I do not want you guys packing up right now. It will irritate me and I will keep you guys after school. So I sub 1 is 10. I sub n, why did I say I? Thank you. A sub n is going to be when I substitute in the last number, which is 12. Twelve plus 4 is 16. The total number I have is 6 to 12. So if I count on my fingers, 6, 7, 8, 9, 10, 11, 12, I have how many? 7. And remember I told you 12 minus 6 is 6, but I subtracted the 6, so I got to put it back in. So 12 minus 6 is 6, plus 1 is 7. Okay? I keep saying it, hoping people are going to get it. I've said it every time, but I don't think you guys are still. It makes complete sense to me in my head. 12 minus 6 is 6, but since I subtracted the first one, I'm going to add it.
Why? Why would you do that?
12 minus 6 is 6 plus, see how I'm always adding another 1 in there? I'm taking away the first term, so I have to give one more. Count on your fingers. It's actually a formula. That's how they teach it originally in Algebra 2, but I always count on my fingers anyways. Okay, so I'm almost done. So I have all the pieces of information I need to get my sum. So the sum of this series, which has 7 terms in it, is the first one plus the last one times how many we have, all divided by 2. (10 plus 16 is 26). I can't half a 7, but I can half a 26. 13. And 13 times 7 is... Why can't I do this fast? 91? 91 is my answer. Okay, I'm going to put this on School Loop, but I have to go quick. All right, sometimes, now you see this? Could you add this by just adding? It's got missing values. So check this out. This is what students say. I've got 1 minute. Okay, so I'm going to need 2 formulas for this. You're going to want to hear this. Give me 30 seconds. You're going to need 2 formulas, but you're going to say, which one do I use first? Well, what are we doing? Adding. So I need my series. Okay, so watch what happens. S sub 1, 2, I don't know how many. So I'm going to add the first one plus the last one. I don't know how many, and I'm going to divide by 2. Since I don't know how many, I'm now going to use this one. I've got the colors wrong, and I'll fix it for the thing. So A sub n is my last term, which is 88. I know my first term, it's 3. I know my common difference, I'm going up by 5. 88 equals 3 plus 5n minus 5. This makes negative 2 plus 5n. Add 2 to both sides is 90. Divide by 5, n equals 18. Now I've got n, it's 18. Go. Yeah, then you substitute back in and finish it. So if you can't find n, this is how you can find it. Good job, guys.